This tutorial shows how to use the Eclipse to Exotherm conversion utility. Eclipse will export grid cell data, well connection data, well completion data in ASCII format. The grid cell data is normally in the star grid ECL format. It has corner point geometry like chord, Z-con, chord, Z-con keywords with associated corner point geometry data, and potentially it has porosity, permeability, saturations, and other grid cell data in that file as well. The completion data is a com.dat keyword, and the well connection cube data shows the trajectory of the wells. So this is the kind of data that we would get from a typical Eclipse generated project. So if you were to start this utility, we will want to open up first of all the data file, which is the grid ECL file, and looking for the grid ECL file in my computer here. I'm going to look for that file, and then Exotherm demo, Petrel conversion, and the grid ECL dot file here. So I'm reading in that file and taking that Eclipse data, and there's a keyword read but not translated. We just say OK. Here's an option to convert corner point geometry to an equivalent Cartesian grid. Normally we do not do so unless the corner point geometry grid is very uniform. If the grid is distorted, then we should want to keep it as a corner point geometry format, at the expense of having much more data to describe the 8 points of each grid cell. So we would say in this case that we are not going to convert that geometry to a Cartesian grid. Say no. So it's reading that file and carrying on reading, and then it finds the keyword permeability, which is not a valid Eclipse keyword. The valid Eclipse keyword is perm_x. So if you come across any keywords that are not valid Eclipse keywords, you have to enter the valid Eclipse keyword. So it's OK for that, and then it's import completed. So now we've completed that, and with any additional information like well completion that file, we should now open them and import them. So we have both the grid cell data and also the well location data. And then we want the well perforation data, which is the well connection file. And in that file here, we want to see the well connection file. So once we got that, we read them all, and if there are any errors, we can look at the log file and see what kind of errors that or messages that we have missed, anything that we not converted properly. Then we do file, we save to Exotherm data file format. In this case, it is an Exotherm format. So we save that as a Petrel converted. It says yes, it's an Exotherm data format. It writes out the corner point geometry, the key is for a porosity array, permeability array, initial saturations, and well locations, and save that. So now we can exit that. So if we look at the preprocessor now, we can open up the file in the preprocessor, and looking at the file in the folder I had just saved to. Petrel converted data file. If you open it, we can see that in the grid cell data, This is corner point geometry, say yes. And it's got the porosity, permeability, corner point sizes, and if you look at, say, porosity, for example, and look at this is going to be going through layer 1, and going to go forward, cross-section forward, control forward. This is the converted Petrel file. You get cross-section XZ. It's corner point geometry, so it's distorted. Cells. Okay. So this is an example of how to convert and then look at the Eclipse data in an Exotherm format. Thank you for your attention.